Okay, I think I'm going to start right now. Hello, everyone. Thank you for coming today. Today is our next to last lesson. And today we're going to be covering percent yields, and we're going to start our review of everything we've learned in this course. So today I want to try something new when we get to the final review part. I've just learned how to do the polling thing on Zoom, and hopefully I can get that to work today. So I'm going to ask the polls, and you can click on a button and respond. But we'll do that during the final review part 1. That's when we're going to start the polling and seeing if it works. Hopefully it does. So for this week, like every other week, there's going to be 4 questions in Google Forms quiz. I would highly suggest you to do it. I think this homework is going to be our last homework I'll assign this course, because the next homework is the last one, and I usually don't assign homework on the last lesson. And as always, I'll give written feedback and post your grade, and this is your last grade. And if you have any questions, feel free to contact me as always. So today we're going to start with percent yields, and then we're going to do a final review. And that's what I was talking about earlier, about trying the polls, and hopefully that can work out. So let's get started with percent yields. So I want to first talk about theoretical yields and what a theoretical yield is, and then we can understand what a percent yield is. So often cases in the real world, most chemical reactions don't go to completion. This can be due to a variety of factors like impurities. So your starting materials or reactants aren't pure, or there's something in the air reacting with your reaction that makes it not react, or it just doesn't react all the way because it wasn't stirred properly. So there's so many reasons why most reactions don't go to completion. And sometimes it's the reaction's fault itself. Like it's not a good reaction and it doesn't get 100% completion due to equilibrium or something. So the theoretical yield, in its name, it gives what it's supposed to say. It's how much should form theoretically. Like if you do stoichiometry, which is what we've been doing for the last, I think, 6 or 7 weeks, that's the calculations of how much we expect the product should form. So we actually did a lot of these calculations last week when we converted grams to grams. So in a chemical reaction, if we let me give an example. I think it's the easiest to learn from an example. So let's do CH4, reacting it with oxygen. And what would form is carbon dioxide and hydrogen gas. But it's not balanced. There should be a 2 here and then 2 here. But don't worry about balancing a reaction. So this is just a chemical reaction. So this CH4 is actually methane. It's a common hydrocarbon that exists in the real world. And we're reacting it with oxygen. And we're forming carbon dioxide, which is the gas we exhale, and water. So the grams to grams conversion is like if I have like 5 grams of methane, how many grams of carbon dioxide should we get? So that's what I mean from a gram to gram calculation. So when we do the calculations, we're going to get a theoretical yield. So theoretical, this is not our actual yield. So if I do the calculation out and I get let's just say I get 10 grams. This isn't the correct answer, but let's just say a hypothetical scenario, we do the math and we get 10 grams. Well, in the lab, if we actually do this reaction in the lab, we're probably not going to get 10 grams. We might get 9.8 grams. We might get 6.7 grams. And we may even get 0 grams. They're all possible. Now, one thing that's not possible is getting 11 grams or 10.5 grams. The reason is the limiting reactant Theoretical yield is what we should actually get. If we get anything over, that means we did something wrong and we measured the wrong weight. So we can get under our theoretical, but we could never get over unless we're adding extra weight. So that means our compound's probably not pure. So I do want to review 1 gram to gram calculation, and here's our reaction that I just talked about. Methane plus 2 oxygen molecules yields a carbon dioxide molecule and 2 water molecules. And I'm actually going to walk through one of these calculations again, just so we can review. So it's a grams. We have 16 grams of CH4, and we want grams of carbon dioxide. So if you remember, we do grams of CH4, and we convert that to moles of CH4. And our secret way of converting is molar mass. And then we convert moles of CH4 to moles of CO2. And that's the balanced reaction. And our last one is moles of CO2 to moles of water. Moles of CO2 to grams CO2. And that's molar mass. So we have 3 calculations we need to do, and we've been doing these calculations a lot. So the molar mass for CH4, let me write in yellow, it's 16, because carbon is 12 and hydrogen is 1, so 12 plus 4 is 16. And the molar mass of carbon dioxide is 44. Carbon is 12 and oxygen is 16, so 12 plus 16 is 44. So I'll do one calculation straight from the beginning to the end. So we always start with what we have in these questions. So we have 16 grams of CH4. Our first step is the molar mass. So we know the molar mass is 16. We want the 16 grams to be on the bottom. So molar mass is grams per mole. And we want the 16 grams to be on the bottom, so we could cancel out grams. 1 mole of CH4. Sorry for my sloppy handwriting. The units cancel out, which is exactly what we want. And then we get 1 mole of CH4. So that means our first step is done. Now we have moles of CH4, we want to get moles of CO2. The way we do that is our balanced equation. I'm sorry it's hard to see, but here's 1 for CH4 and 1 for carbon dioxide. So it's a 1-to-1 mole ratio because the balance coefficients are both 1. So 1 mole of CH4 yields 1 mole of CO2. And as always, the moles of CH4 and moles of CH4 cancel out. And we're left with 1 mole of CO2. So we now have the moles of CO2. So now we need our final answer, final step, I should say. So we bring down the moles of CO2 and we do the molar mass. It's 44 grams per mole. And this time we want the moles to be on the bottom to cancel out the moles on the top. So we have 44 grams of CO2 per 1 mole of CO2. The moles cancel out, and we're left with 44 grams of CO2. So let me emphasize, if we do this in the lab, we probably won't get exactly 44. That's our theoretical. So theoretical formula, the theoretical is how much we expect to get if everything was perfect in a perfect world. So this is the 3 steps that we need to do for these calculations. And yep, it's 44 grams. So that's how you would do it in a theoretical sense. But now we're going to introduce something called percent yield. So first we need to do like the actual yield. So the actual yield is how much we actually formed. So we'll use a scale and we will weigh it at the end, and that scale will tell us how much we actually got. So for a short calculation here, let's use the previous problem, the theoretical. Is 44 grams, but we got, let's say, 43 grams. So that's pretty close. We did a pretty good job. So the percent yield is the actual over the theoretical times 100. The reason we times 100 is because we want to make it a percent. So percent means we have to multiply it by 100. So let's calculate our percent yield for this. So our percent yield, so it's the actual over the theoretical, which is the actual is 43, the theoretical is 44, and we multiply it by 100. So the answer we get is about 97.7%. So that's a percent yield. And these calculations are pretty easy. You just need to know your actual, you need to know your theoretical, you divide the actual by the theoretical, and you multiply by 100. So I'll do one more example, and then we're gonna have some practice problems that I want you to type into the chat when you got the answer. So the theoretical yield is 44 grams of carbon dioxide in this equation. If only 33 grams of carbon dioxide actually formed, what is the percent yield for this combustion reaction? So this reaction type is called a combustion reaction. The reason it's called combustion is we're reacting our molecule, which is CH4, with oxygen. And we always form carbon dioxide and water in a combustion reaction. So to calculate the percent yield, it's the actual over theoretical times 100. So that's our formula. The actual yield, let me see. We can literally look. The actual yield is right here, actual. And the theoretical is right here. So it is a pretty easy calculation. So you just put in actual is 33 and theoretical is 44. So I would be careful and not invert it, because that's a common mistake. So make sure to put the actual on the top and the theoretical on the bottom. And then you do your math and you get 75%. So they're pretty much easy. So that's all there is to these types of questions. So now we're gonna have, I think 2 or 3 practice examples of this type. Can't remember. And it's all gonna be the same equation. So let's say the theoretical yield of carbon dioxide is 100 grams. If 89% actually formed, what is the percent yield for this reaction? So please type in your answer in the chat when you get it. This should be a pretty easy problem, but it's also important. In chemistry, you always want to know how effective your reaction is. As one with a high percent yield, it means it's a pretty good reaction. But if you only get like 5% yield, it's probably not that good. So I'll give you another 30 seconds to answer it.
Wow.
Okay, so now I'll do the answer. Everyone who sent who answered it got it correct. So let me check this chat 1 second. Okay, so the calculation is percent yield. So I usually don't write percent. I usually just use a symbol. Percent yield is actual over theoretical times 100. So I said actually formed, so that's 89 grams over 100 grams times 100. So that's 89%. I do want to point out, notice that we have grams on the top and the bottom for our calculation, and the grams cancel out because we divide by the units. So percent yield is unitless, except unless you count the percent as a unit, but it's not really a unit. So make sure you don't do like 89 gram percent. It's just 89%. That's another common mistake I see a lot of people making. They put units for percent yields, but percent yields do not have units. So good job, everyone. Okay, let's try another one. So please type in your answer, private message me to the chat when you got the answer. And please don't send it to everyone so everyone has a chance to answer and they won't get the answer beforehand. So this time the theoretical yield is 50 grams for water, but only 22 grams of water actually formed. What is the percent yield? Notice how in this case, we're not doing carbon dioxide, we're doing water. But the calculation doesn't matter which compound it is. They're all the same. It doesn't matter if it's the reactants or products, but we usually don't do percent yields for the reactants, but I'll give you another minute to try to think through the calculation. It's basically a plug and chug, but it's important. Okay. I think I'll start with the answer or the solution. So percent yield it's the actual over theoretical times 100. So the hardest part is getting the right number. So the actual is 22 grams. The theoretical is 50 grams, and you multiply it by 100. Notice you could do some arithmetic. 100 times 50 is 2. So that's 44%. Or you could just use a calculator. Either way is fine. Yep, 44% yield. Okay, that would wrap up our percent yields calculation. They're pretty much that easy. There's not much more you can ask about them unless you make them do the whole gram to gram conversion to determine the theoretical. In that type, the calculation is quite long, but I'm not making you guys do that. So now we're going to have our final review-ish part 1. So I'm going to try to experiment with the poll on Zoom. So I would appreciate your cooperation with me on doing that today, since it's my first time and I don't know if it will work. But there's a few theory and then there's some poll questions that follow it. So I want to review density because I believe that's an important concept. Density is defined as mass over volume. In equation form, that's D equals M over V. And the interesting thing about density is it's constant for a certain substance. So the density of a gold is always constant. Density of a pure substance, I'm sorry. So it's something that's pure. Pure gold is always have a constant density. Water has a constant density of 1 gram per milliliter. So the density of gold is 19.3 grams per centimeters cubed. So let's do this calculation. This one's not a poll question. This is just for me to do one with you. So this is a easy density problem. So if an object has a mass of 15 grams and a volume of 10 centimeters cubed, find the density. So in a density is mass over volume question, we always know two variables and we're going to solve for the third. So we're given a mass and a volume. So we're going to solve for density. So we just plug and chug. So the mass is 15 grams and the volume is 10 centimeters cubed. Put that in a calculator, you get 1.5 grams per centimeters cubed. And it's that easy. There's not that much more to density questions. Oh, whoopsies, sorry. And as you can see, that's exactly how you solve it. So this is my first poll question. So I'm going to read it first, and then I'm going to release a Zoom poll, and I would like it if everyone answers. So a piece of metal wire has a volume of 20.2 centimeters cubed and a mass of 159 grams. If we know that the metal is manganese, iron, or nickel, which metal is it? And we're given the densities of the three metals. The density for manganese is 7.21. The density of iron is 7.87. And the density of nickel is 8.90. So I'm going to launch the poll. So if you think it's A, manganese, click A. If you think it's B, iron, click B in this poll. If you think it's C, click C. If it's nickel, click C in the poll. You don't have to be right, but this is a way for me to know if you understand the material. And the way to solve this problem is you calculate the density of this metal wire and you compare which density is closest to it. So if you get like 7.21, you would say it's manganese. That's the one closest to it. If you think 7.87 is the closest one, then that one. And yes, someone in the chat said there's a D. Yeah, in some future questions, there will be a D. So I'm sorry I didn't make one just if there's three choices. But in the future, I think next few problems, there's actually a D. So I'll give you guys 20 more seconds. So please vote. It's okay to be wrong. I learn from my mistakes when I get problems wrong too, so there's nothing to be ashamed of. Okay, I think I'm gonna end polling right now. So thank you for the 7 people who voted. I would suggest everyone to vote in the next problem. But as you can see, the consensus is that the answer is B. Let's actually do the calculation and see if that's right. So we calculate the density is mass over volume. So the mass is 159 grams and the volume is 20.2 centimeters cubed. So put that in your calculator, which I'm doing right now. You get 7.87 grams per centimeter cubed. So which one is the closest? Look, iron is the closest. So that means it's B, iron. So great job, everyone. You guys did well. You got the right answer. So that's how a density question is. They might not be straightforward, but it's using density to find the identity of a substance. Okay. So let's clear. So we have a similar question right here. So I would like everyone to look over it. It's the exact same thing, same 3 metals, except it's a volume of 15 and a mass of 134 grams. So I'd suggest you guys get out your calculators because it's kind of hard doing it in your head. And I will launch the poll. And it is launched. So the numbers are different this time. So I'll give you around 30 more seconds. Fifteen more seconds. Okay, I'm ending the polling, and here are the results. We were all over the place on this one, but I see a majority of you said C. So let's look and see if you guys are right. So the density is mass over volume. As always, I've given you the mass and the volume. And our answer is 8.93. You might be wondering, oh, that's not any of them. But we look at the one that's closest, and that is nickel. So C is the correct answer. Good job, guys. So that is good. Okay, so let's try this problem. This is a US NCO, which is a National Chemistry Olympiad. If you guys like chemistry, sorry. If you guys like chemistry, I would suggest you to participate when you get in high school. It's similar to like math competition, but this one says 5 pellets of metal have a total mass of 1.25 grams and a total volume of 0.278 milliliters. What is the density of this metal? So let's share the poll. Okay. So this one has a D, so. I'm probably going to give you guys a little more time since this one is a little more math based. And you guys do need a calculator if you have like an iPad or a phone. It might help a lot. Like trying to do these calculations in your head might be a little harder, but it's doable. I've seen 5 people have already voted, so that's a good sign. Okay, I'm gonna end it. So thank you for everyone who voted. Here's the results. The majority of you guys said C, which is the correct answer. So let me do the calculations. So there's a lot of words, but you can see the total mass is 1.25 grams and the total volume is 0.278. So density is mass over volume. The mass is just 1.25. The volume is 0.278. And you put that in your calculator, you get 4.50, which is C. That's how you do it. I know this one was a little tricky since it said 5 pellets of a metal, but it doesn't really matter how many. Because 5 pellets of a metal has nothing to do with the problem. It could be 10 pellets of a metal. It'll be the exact same way. So they just added a little extra words to make it trickier. So good job, everyone. Now we're going to go back to atomic theory review, and that is what our next review is going to be about. This is going to be all we're reviewing today, the atomic theory. So the subatomic particles. So there's 3 particles, the protons, neutrons, and electrons. Protons lie in the nucleus. They're positively charged, and they have a mass of 1 AMU, or atomic mass unit. That's what they defined an AMU, the mass of a proton. Neutrons, they lie in the nucleus as well. They're neutral, given their name, and have a mass of 1 AMU as well. They're slightly heavier than a proton, but only slightly. And electrons, they lie outside the nucleus. They orbit the nucleus. They are negatively charged and have negligible mass. So they have a mass that we don't even have to consider most of the time. So each element has an atomic symbol, which is a 1 or 2 letter notation that represents an atom. For example, H, which I'm hoping all of you are familiar with now, is the atomic symbol for hydrogen. He, helium. As you can see right here, that's helium. Au, that's gold. So that I know hydrogen and helium, you could probably expect to know what elements, but like sometimes you get weird ones like Au. That's because it's in a different language. And Ag is silver, which is also from a different language. So now let's review atomic number, which is abbreviated as Z. So atomic number, Z, is the number of protons in the nucleus of an atom. An element is a, okay, so let me go back a little bit. So as you can see in this picture, there are, the protons are positively charged. Remember, protons positive. So there's, in this, there's 2 protons, there's neutrons, I'll have green. How you can tell neutrons apart, they're neutral, they don't have a charge. There's also 2. And then electrons, there's also 2. In this case, they all happen to be 2. It's not that case in every single atom. In every single neutral atom, the protons and the electrons are the same. In neutral atom, there's the same number of protons and electrons because nature doesn't like charges, unbalanced charges. An element is a substance whose atoms all have the same atomic number. So in this case, the atomic number, Z equals 2 because there's 2 protons. So the atomic number is 2. So that's how we do these. So let me launch this poll. It should be relatively much easier than the density calculations. So what is the atomic number Z for lithium? And lithium has a symbol Li, just FYI. And remember, the atomic number is the number of protons. Oh yeah, and another thing is these polls are anonymous, so I really can't see who voted what. So don't be shy on voting. I really can't see, and it won't even be saved. So there's no harm in voting or responding to this poll. I'll give it another 20 seconds. And see, right now 5 out of 9 people have voted, so thank you to all who already voted. So remember, the atomic number is the number of protons, and you could look at the key and see which one are the protons, or you know that protons are positively charged. So I'm going to end polling right now. Let's share the results. A majority of you said A. And A is the correct answer. As you can see, there are 3 protons. Let me number them. 1, 2, 3. So Z equals the number of protons, which is 3. So that's A. So let's do that same exact thing for nitrogen. So what is the atomic number? In this case, they don't have the charges, but a P stands for proton. So basically, can't find the atomic number. To find the atomic number, you find the number of protons and you count how many protons there are in that element. I'll give you around 30 more seconds. Please respond. There's 3 more people who haven't responded. Okay, I'll stop it now. Let's share the results. So the major consensus is B, and that is correct. Whoopsies. I'm sorry. I don't know what happened. Okay. So we basically count the number of protons. The atomic number is number of proton. And I'll label them 1, 2, 3, 4, 5, 6, 7. It's 7, so it is indeed B. So that's atomic number. You'll definitely need to know what atomic number is in chemistry class. That's pretty important. So now let's review elements. Elements must have the same number of protons or atomic number in each atom. So they, an hydrogen atom always has 1 proton. A helium atom always has 2 protons. So if you know an atom has 2 protons, you know it must be helium. But elements may have different number of electrons, and they're called ions. That's because they could either gain or lose electrons. And elements may have different number of neutrons, and those different neutrons are called isotopes. So one example is the most common isotope of carbon is carbon-12, but there is also isotope carbon-14. And this is used for radioactive, determining the age of a species. They use carbon-14, that isotope, to determine the age by its half-life. So they may have different number of electrons or neutrons, but they must have the same number of protons. Now let's define atomic mass, which is a pretty simple term. It isn't that complicated. So the atomic mass, or the mass number, is the total number of protons and neutrons. So it's basically how much it weighs, because electrons basically weigh 0 and neutrons and protons weigh 1. So we're basically figuring out how much it weighs, which is the number of protons and neutrons. So let's do an example for this. Helium atom to the right. Again, it's helium since it's 2 protons. So the proton number, which I'll abbreviate P, is 2. And the neutron number is also 2. So atomic mass, which is A, is 2 plus 2, which is 4. So the mass right here for this atom is 4. Or you could literally just count them. Let's see. 1, 2, 3, 4. You're counting neutrons and protons, but not electrons. You don't count these. So they're that simple. Let's do an example one. Let me relaunch the poll. So please vote. It's like, what is the atomic mass A for lithium? Basically, you count the number of protons and neutrons. I know it's kind of hard to see the neutrons in this picture. I'm sorry about that, but I'm waiting on 3 more people. Thank you for the 6 that have already voted or answered the poll. Not really voting. I'll give it 15 more seconds. After this question, there's one more question, and that will be the last question for our review for today. Okay, let's end the polling. So this one was our first unanimous poll. So good job, everyone. It is indeed C. So let me just work it out, although I know all of you know how to do it. So the number of protons is, as you can see, 1, 2, 3. So that's 3. Number of neutrons is 1, 2, 3, 4. So the atomic mass is the sum of how much everything that weighs something is. So 3 plus 4 is 7. So that is C. Great job. And then we're going to end the problem with the one that's a little more harder to see. So we want, it's the atomic mass again, but this time it's for nitrogen. So let me relaunch the poll. Okay. So it's visible now. So what is the atomic mass for nitrogen? This one's a tricky one. Please don't miscount. I know it might be a little hard to see on the screen. But we want the atomic mass, or how much it weighs. Remember, electrons usually don't weigh anything. So it's the sum of protons and neutrons. And the atomic mass review, it's the number at the bottom of the square on a periodic table. So a periodic table has the atomic mass. Well, it's more like the molar mass, which is a weighted average of all the different atomic masses of different isotopes. So it's slightly different. Since this is hard, I'll give it another 45 seconds. Thank you to the 5 who already voted. You guys did very well on this problem, actually. Right now, you guys all said the exact same thing. But I'll wait a little bit. $15 and I'll end it. Okay. So great job. It was unanimous. You guys all said D. And just as a refresher for all those who don't understand this concept yet, it's the number of protons plus electrons. Protons, we basically just count the number 1, 2, 3, 4, 5, 6, 7. Neutrons, there's 1, 2, 3, 4, 5, 6, 7. 7 plus 7, 14. So in the next review, we're going to put this together and get the nuclide symbol. So if you remember, it was A, Z in the elemental symbol. So like 12, 6 carbon. That's one example. In this case, it'll be 14, 7 nitrogen. But that's what we're going to do next week, as well as review some more stuff, including calculations. We're going to cover everything else we haven't covered, like is it a metal, non-metal, and all that. I hope this style of the polls is more engaging for you guys and entertaining, because that's what we're going to be doing next week as well. We're going to continue using this poll feature. So today we did percent yield and we did a final review, which I thought was pretty successful. For our homework this week, there's going to be 1 question on percent yields, which is a simple plug and chug, and there's going to be 3 final review questions on the homework. I suggest everyone to do it. This homework is pretty easy this week because there's no big number calculations like the last few weeks. I know those were kind of more calculation based. And there's 4 homework questions. And I would like to mention next week will be our last week, and it's next Tuesday. And we're going to have a final review, and I'll try to cover as much as we can about all the other content that I haven't gotten to yet. And we're going to review that with the polling. And thank you for attending class today. I hope to see you next Tuesday. Bye, everyone.